Okay, let's look at the last little bit of our concentration unit, this last bit of chapter 14. And this time we're going to look at the dilution of solutions. So we've talked how concentration is the ratio of solute to solvent, and we can use the ideas of equivalent ratios and simplifying ratios in order to find concentrations that are the same but for different volumes. And what we're going to do with dilution is looking at what happens when we don't add any more solute to the solution, but we add water. So we change the concentration, but we keep the number of mole the same. Okay, so we're looking at a situation where the number of mole is constant, but the volume changes. Okay, so this means that we can work backward from a dilute solution to work out the more concentrated one, or start with a more concentrated solution and work to a dilute one. So in this way, we can dealing with the cordial concentrate and making up a solution of just the right concentration that we're after. So this is a very common task for chemists to do because we will be often given stock solutions. So these are a concentrated solution and then dilute this down to the different concentrations that we need. In particular, when we're doing an investigation, if we're investigating different concentrations, we may start with 1 molar and then dilute this down to 0.5 molar, 0.25 molar, 0.125 molar, and things like that in order to get a serial dilution or a range of concentrations that we can do our investigation over. So when we do this, we don't change the composition of this solution at all. So this means that we're not changing the solvent. Okay, so we're not changing the solute, sorry. We are just, and we're not adding a different solvent, we're just adding more solvent. All we're doing is adding more solvent. Okay, so the number of moles doesn't change when we dilute a solution. So we're given the dilution formula, and I would refer to this as dilution. This can only be used when we have an initial and a final situation where we're adding water. Okay, it's only used for dilution. If we're mixing two different solutions or anything like that, it can't be used. It's only when we take one solution and we're adding water to it. Okay, so we can't use it if we're adding solution A and solution B together. It just doesn't work. So when a solution is diluted, the space between the particles is increased. We talked about this in class. So the dilution formula shows the relationship between concentration and volume for a given mass of solute. Okay, so this is that C1V1 is equal to C2V2. Again, we're looking at ratios. So what we're saying is that the concentration initially multiplied by the volume initially is equal to the concentration in the final situation multiplied by the final volume. Okay, so the key thing with this is it doesn't matter what our concentration units are or our volume units, the units just have to be the same on both sides. Okay, so it doesn't matter if my volume is in litres or milliliters or decimeters cubed or anything like that. What does matter is that they are the same on both sides, and I remember what my final answer will be in because I may need to change it to the concentration that the question asks for. So let's have a look at a couple of different example questions. This one says a student adds 600 ml of deionized water to 50 ml. This one is important because remember we're looking for initial and final situations when we do these. Okay, so our initial is going to be 50 ml. Okay, so this is going to be our V1, but then the students add 600 ml. So our V2 volume is actually going to be 600 plus 50. This is important when we're dealing with dilution situations. We need to look for the is made up to, okay, which means that that will be our final volume, or in this case is added to. So we have to add the two volumes to get our final volume. And then this is our concentration. So this is C1. Okay, so we're asked to determine the concentration of the diluted hydrochloric acid. So this is after dilution. So this is going to be C2. So I'm going to write my formula. C1V1 is equal to C2V2. I'm looking for C2, so I'm going to rearrange. There we go. And then I'm just going to substitute in. So in this case, my concentration is 0.35. And then my volume for V1 is 50. And then I'm going to put my second volume, which is 650. Put this into my calculator. So I'm going to get 0.35 multiplied by 50 and then divide all of that by 650. And I'm going to get a final concentration of 0.0269, and that will be moles per litre because that's what my initial concentration was. Okay, so this is going to be much more dilute, which makes sense because we've diluted it by quite a factor. Okay, so now this is what our final concentration would be, 0.0269 moles per litre. So that's a simple substitution in finding the second concentration. Let's look at our second example. You can pause the video and try and do this one yourself and then come back and see what the answer is. Okay, so hopefully you had a go at this one. We have a concentration here. So this is going to be my C1 concentration. I know it's concentration because moles per litre. Sulfuric acid was formed when diluting a 2 mole stock solution. So actually, to read the question all the way through, this is my C2 because it says was formed. So this is my final solution. This is the solution that I started with. Stock solution means more concentrated. Stock solutions are always concentrated, more concentrated than the final solution. So the diluting a 2 mole stock solution to 50 mil. So this 2 means that this is my final volume. Find the volume of stock solution used. So I want to find V1. So again, C1 V1 is equal to C2 V2. I'm going to rearrange this time to find V1. So V1 is going to equal C2 V2 over C1. Going to substitute in from my values. So C2 was 0.70. V2 was 50 milliliters. Okay, and then divided by 2, which was my original concentration. So 0.7 times 50 and then divided by 2 is going to be 17.5 milliliters. Again, we're usually used to using things like liters with our concentrations and stuff like that, but I know it will be milliliters because it will be the same as the volume that I put into the calculation originally, and my two concentrations are the same. So as long as they're the same, then it doesn't matter because we're just looking at a ratio here, so it's all good. Okay, so that means that you're all ready to tackle the questions on page 358, questions 1 to 4. If you haven't been able to do those so far, I know that dilution was in the Education Perfect content that you covered as well. So good luck with that, and remember to come to class on Friday with any questions that you have, and I'll see you in class.